Welcome everyone to Wednesday Night at the Lab. My name is Dylan Brewer and I'm a student worker here at the Biotech Center. On behalf of the Biotechnology Center, UW-Madison Division of Extension, Wisconsin Public Television, Wisconsin Alumni Association, and UW-Madison Science Alliance, welcome to Wednesday Night at the Lab. We do this every Wednesday, 50 times a year. Tonight, it is my pleasure of welcoming Kurt Kottenberg. All right. Tonight, Kurt will be sharing with us about Wisconsin weather safety. Before we get started, we're going to ask Kurt the 5 questions.
If you dare. No one threw anything at me. That's good. Obviously, the weather was hot and whatever today. I was planning to dodge. So, all right.
All right. Kurt, where were you born?
Madison, Wisconsin. So this is home.
All right. And where did you attend high school?
Madison Memorial High School.
All right. And where did you go for undergrad?
I went to undergrad and graduate at Wisconsin Milwaukee.
What did you study while
that's good. Yeah, I got my bachelor's in atmospheric sciences and a master's degree as well in atmospheric sciences.
All right, awesome. And where did you go for any advanced degrees?
So I stayed there at UW Milwaukee. And then in my weather service career, while I was working in Des Moines, Iowa, I actually got my MBA from Iowa State. So a couple of universities, a couple degrees, but yeah, just like learning, like sharing information, so.
Awesome. Everyone, please join me in welcoming Kurt Kottenberg.
All right. Those were easy questions. I was thinking like gravity waves or something about sinusoidally transsectionalizing jet patterns. So we'll take those questions. Where were you born? Yes. So first off, thank you all for watching and joining us here. I'm Kurt Kottenberg with the National Weather Service in Green Bay. We're just going to talk a little bit about weather safety and kind of start with what we do here at the National Weather Service. So a little bit of history. We'll start off with a history quiz. Does anyone know who this person in this picture is? And a hint, if you went to UW Milwaukee, I heard a Lapham back there, yes. So at UW Milwaukee, there's actually a building named after him. This is Increase Lapham. And there's Lapham Hall at UW Milwaukee. And I believe he's actually buried somewhere in the Milwaukee area right now. He's kind of like the godfather of the National Weather Service, if you will. So it started way back in 1870. He messaged President Ulysses S. Grant at the time. And he said, he's like, we're doing a lot of shipping and stuff here on the Great Lakes. I think it'd be great if we could have like an observation network, like across here and, Minnesota to get weather observations. Because if we had those informations, then we could share it with the ships and I could predict the weather. So can you do something about this at the, presidential level? And sure enough, 1870, we just had our 150-year anniversary of being a National Weather Service. So the mission has gone from, hey, can you help take observations so we can help ships on the Great Lakes to where we are today. And in the bottom right corner there, that was actually an addition made within the past, 2022, the impact-based decision support services to our mission statement. So otherwise our goal is to just protect life and property. That's one of the things I love about the Weather Service. Like, I don't care about getting clicks or fancy anything. Like, we just do the weather. Protect lives, protect property. The impact-based decision support services, that's one big direction where we're going. So like our swim lane is helping with our first responders and our government partners. So like police, fire, emergency management. We provide support for them. So say, like heaven forbid, there would be like an airplane crash or something. And you have like all the first responders swarming in to contain the scene and help with everything. What if there's storms coming in? They might not know or, anything like that. So our job is to help with things like that and let them know the weather so that they can do their operations and do what they need to do and have like their personal little forecasters there to help them so that they stay safe as well while they're trying to protect everyone. So some tiny print here. It's kind of like it starts really big at the top. We do the warnings, like tornado warnings. So people ask, like, what television station are you on? I'm Kurt, I work for the Weather Service. What TV station? Are you on Channel 5? Like, no, we're behind the scenes. Like, you don't want me on TV every day, I assure you of that. So we do behind the scenes. We issue like the severe thunderstorm warnings, tornado warnings, excessive heat warnings for days when it's 110-degree heat index, like today. So we do that. Those are the things that the public sees. But also, like, getting down to the small print there, like, we do so many other things like radars, satellites, because all that weather information has to come from somewhere. It's like when you're looking, the TV person shows like the television satellite, like that comes from like the Weather Service helped and NOAA like launch that satellite into the air. So we do all the things like the forecast models, like all that behind the scenes stuff. We also help with river forecasts and hurricane tracks, hurricane forecasts. So we do a lot of things behind the scenes. Overall, we issue about 1.5 million forecasts and 50,000 warnings every year. And what I've always told the people is we cost about as much as a Big Mac for taxes, but that's no longer true because the cost of a Big Mac has actually gone up more so than our funding has. So we cost like half a Big Mac now to run the Weather Service. So, and it's interesting too. There's actually a study done by one of my professors at UW-Milwaukee that we actually provide a net positive return on investment for taxpayers. Aside from obviously the life-saving portion of it, but we also do aviation forecasts. So, like if you're flying from say Milwaukee to Denver, and there's thunderstorms in the forecast, by the FAA regulations, that plane would have to carry extra fuel. So, it could circle the airport if it needed to. And, as we know, the airlines, if it costs them to carry extra fuel, are they gonna just be like, oh, that's fine, we'll eat that cost? Or would they say, well, let's boost ticket prices a little bit because of these fuel costs? Like, we're gonna go with that one, they're gonna boost prices. So the accuracy of our forecast is also something that's very important. So we have 122 offices across the country. So a lot of them, we have office in Hawaii, Puerto Rico, Guam even. We have out in the Hawaii area, they do like tsunami forecasts. And then here in Wisconsin, we have 5 offices that serve the state of Wisconsin. So Green Bay, La Crosse, Milwaukee, Minneapolis, and Duluth. And we operate 24/7, 365. So when Santa's flying around, we're helping him forecast. New Year's Eve, we're ringing in the New Year's with at least 2 forecasters at all of these offices. Rotating shift work isn't the best, but that's the way weather works. Weather doesn't do a 9 to 5 Monday to Friday, so someone's got to be there. So that's a little bit about the background for what we do. And we also do things like this, like public safety talks, education talks, because that's very important as well. A very key component to the protection of life and property is knowing what to do to keep yourself safe. So we'll talk about kind of the 4 seasons weather here in Wisconsin. This isn't San Diego or San Francisco where it's sunny and 70 every day. Take today, it's gonna, 110-degree heat index. Then in 48 hours from now, the temperature is gonna be like 65, and we're not even gonna hit 70 for a high in some places in Wisconsin. So just kind of the yo-yo weather. So starting with convective weather season in the spring and summer, what I always tell people, and a hint, this slide might appear again. Like this to me is like probably like the most important slide in my opinion. So if people ask me like outright, like what can I do to keep myself and my family safe? Like this is exactly it right here. So wake up in the morning. So it's just like knowing what to expect for the day and not being caught off guard or the whole it came without warning. Like that dovetails into like, oh, you guys are paid to be wrong half the time. Like that's just not true anymore. Like the computer models have gotten really, really good. And so like the heat index for today, for example, like we had this in the forecast. We were eyeing this up like 6-7 days ago. If you think back to the March 31st tornadoes that were in southern Wisconsin and in Iowa, I think eastern Iowa had like 29 tornadoes or something on March 31st of 2023. We had that like 6 days in advance, like, hey, it's gonna be stormy, hey, it's gonna be stormy. So, like we've gotten good. Like the weather guessers, like, and not just us at the Weather Service, but like the TV people and the industry as a whole, like the computer models have really come a long way since even 10 years ago. Like the resolution and the scale is just so much better than what it was 10 years ago. Okay, so going back to this slide. So when you wake up every morning or you're eating breakfast, just take 30 to 60 seconds each day and check the weather forecast. Whether it's the Weather Services website or your favorite local TV meteorologist or some other trusted source, just take a look at the weather. And if it's sunny and 72, hey, that's great. But if it's like today, 110-degree heat index, now you know that that's going to happen. And you can think of like, okay, do I have any plans? I'm going to be outside at a softball game that starts at 4 o'clock. That's not good. So then, you can decide, hopefully the game would be canceled perhaps, but if it's not, then you can say, okay, I at least need to drink extra water and those types of things so I can start being prepared. So, the heat isn't even here, the first raindrop hasn't fallen, and already you kind of have a game plan or an action plan to help keep yourself safe. So, this is really, really important just to start early in the daytime. Really quick background here on warnings. So severe warnings. So when we issue warnings, we're looking at 3 things. First off, we take a look at the environment. Again, we can tell like the science and the models have evolved to where we can say like, this environment's not really favorable for tornadoes, but there could be hail. So we'll watch for hail. And then obviously what we're seeing on the radar, and then from spotters in the field, law enforcement, dispatch, public reports, on social media, those types of things. Social media reports relay to local TV people who then relay those reports to us. Like it's a chain, but it works. And so usually if we have like 2 of these 3 things or all 3 of them, then we'll probably issue or strongly consider issuing a severe thunderstorm warning or a tornado warning. And then from there, where does all that information go? So I won't read this word for word, but it goes to a lot of places. So like wireless emergency alerts on your phone, it goes on the TV stations, our NOAA weather radio. Those are still going strong and they'll go strong for a very long time. So just it goes to a lot of places. So keying back to the preparedness portion of it. So if you know there's going to be severe weather or tornadoes possible, think of where you might be at that time. And then think of how you'll receive warning information. If you're at a campground somewhere, make sure you have some way, like some cell phone reception, or there's some sirens nearby, or a friend has a NOAA weather radio, like just some way to get that weather information so that you aren't caught off guard. So again, like the first raindrop hasn't even fallen, and just doing these things, like we're so much more prepared than we otherwise would be. And could be stuck in a bad place. So one of my emergency managers told me this when I was in Iowa. Smart man. So this is kind of when I first got started in weather service. And so I tell people this too, there's like the optimism bias is what he called it. He says like, it won't happen. And then people say, well, if it happens, it won't happen to me. They say, yeah, if it happens to me, it'll be fine, and whatever. And then, someone will save me. But it's not always the case. So again, just make sure that you have ways to receive information and ways to stay safe. A little more numbers here. I know these might be kind of tiny here for the audience. So this is the number of severe thunderstorm warnings and tornado warnings that we have issued at the Weather Service since the year 2010. And so if the question is like, have you noticed any trends in severe weather? Like we're issuing more warnings, less warnings? There really isn't too strong of a signal for an increase or decrease. The year 2023 is kind of right near the middle of the graphic. And it's really interesting. It depends on where you live in Wisconsin. Milwaukee and Madison, the 2023 year is like pretty active because we all had that severe weather in like March and April for a couple days. But if you go up north to Green Bay, to my home, we have the second slowest severe weather season on record right now. So it's the northern Wisconsin's been really quiet. Everything's been happening in southern and southwestern Wisconsin for this year. But 2023 is on pace. It's kind of more or less an average year. By week, So if you're watching this and you're wondering, what kind of, this goes back to 1986, how common or not is severe weather when I'm watching this right now? So towards the end of August, September, we're really starting to kind of get on the off ramp. There is still severe weather. This is comparable to like early May. So there's still thunderstorms, there still could be severe weather, but definitely a downward trend. And then this is data for all of Wisconsin. And it's pretty similar wherever you go in Wisconsin. There isn't much of a difference between the northern part or the southern part. And then the peak of severe weather season is typically middle to end of July is when we see the most. But a couple little blips there in the winter. I know there was that big tornado outbreak in Kentucky, like December 11th. And then December 15th, 16th, there was those storms, and like it was year 2021, there were storms in like Minnesota. So, can happen in the winter, but just not very often. Time of day. Time of day, definitely a spike with the peak of the daytime heating. So again, this goes back to kind of like my safety message of, in the morning, think about where you'll be when there's severe weather. And that 5, 6, 7, 8 o'clock hour is the time where a lot of us are out and about on the patio somewhere or playing golf or softball or something. So again, just that awareness before the severe weather strikes. And then there's a little blip. It actually almost goes up a little bit between like the midnight 1 a.m., 2 a.m. hour, a little bit. But oftentimes what happens during that, like the midnight hour, those storms usually don't produce as much hail or tornadoes, but oftentimes wind is what those ones will produce. And a lot of the times during that time in the morning, those storms actually formed over Iowa during the afternoon, and they've just raced across Iowa into Minnesota. And so we're getting kind of the remnants of them, like they're weakening and getting weaker, but they'll still produce wind occasionally there between that midnight and 2 a.m. hour. And then the lowest is around 8 a.m., 9 a.m. or so. Tornadoes is pretty similar with that 5, 6, 7, 8 o'clock in the evening. And again, you don't really have a lot of tornadoes. If you look at severe thunderstorm warnings and tornado warnings, you don't have a lot of tornado warnings there during those overnight hours. It's usually during that afternoon time. Before severe weather strikes, a great place to go to is the Storm Prediction Center. They have different categories. They might be changing. I think they'll be changing at some point before the year 2030. We're kind of starting to dabble in social sciences a little bit more and realizing that the general public doesn't speak weather nerd like we do. So to like weather nerds, like, oh yeah, enhanced, marginal, that makes perfect sense. But to the general public, like if you ask like, what's worse, slight or enhanced? I don't know. Like they both don't sound good. So, I think at some point over the next 5 to 10 years, these might get a little more, kind of more understandable. But yeah, so these are the current categories. Up here in Wisconsin, we don't typically see the moderate or the high risks. Those are usually well down south in Oklahoma. So good news there. And then this is actually from that March 30th, 31st tornado event. So this is what the Storm Prediction Center had for a forecast. They parse out the tornado on the far left and then damaging wind and hail on the right. So, again, we're not, weather guessers are wrong half the time. Like, this is a pretty eye-opening forecast, or at least it should be. But we were on this, again, days in advance. So, when you see things like this, definitely take it seriously. And then our websites across the state of Wisconsin. So you can just go to any one of those websites. I pick Green Bay, Homer. We'll show mine. But what you do is you go to the website there and you just click on your location. So like say you live in Wausau, in the middle of the state, you just click Wausau and it would take you to the 7-day forecast. And yeah, it has the watches, warnings, it has our weather story in the bottom left, so that highlights the most important things of the day. In this case, it looks like some pretty heavy snow. It shows you the radar, so that's where you can get a lot of weather information. So wrapping this little section up again, make a habit, take 30 to 60 seconds every morning to look at the weather forecast. So, pop quiz for the audience. Thunderstorm watch or thunderstorm warning? Do we know the difference? Okay, so watch means be prepared. Warning means take action. So a watch, we typically try to issue like 3 to 6 hours in advance. You know, if we're seeing those storms at 4, 5, 6 o'clock, we'll issue a watch at like maybe 1 o'clock or 2 o'clock. So that's like an extra like tap on the shoulder, like, hey, just so you know, there might be storms coming later. And then the warning means it's about to happen. So same for tornadoes. That means we've either seen it, we know it's happening, or what we're seeing with those ingredients, that triangle at the front, like the environment and the radar is showing that this could be happening very soon. And we try to give for thunderstorm warnings, our target is like 20 minutes or so. That doesn't always happen 100% of the time, but that's what we try to shoot for. But you know, again, sometimes there's only just a couple of minutes. So when the warning's issued, you know, bam, that means it's time to take shelter. And then along with severe thunderstorms, like it produce tornadoes, produce hail, lightning, wind, and flooding. So a whole gamut of severe conditions. And if you're wondering what makes a thunderstorm severe, it's 58 mile per hour winds or greater and or 1-inch hail. So that was a change that the Weather Service made also in the year 2010. Prior to the year 2010, it used to be three-quarters of an inch sized hail, or like the size of a penny. But basically, a lot of like engineering and people that are far smarter than I am were looking at the data and doing research and was kind of like, you know, like that 3/4 of an inch, that penny-sized hail, like, you know, doesn't really produce as much harm to people or buildings or things like that. But when you hit 1 inch, like that hail starts to be noticeable, like causing injuries or damage to property. So they up the threshold a little bit. So we issue fewer severe thunderstorm warnings, which also helps too, because like we don't want to, you know, cry wolf or anything like that. So we want to mean like when we issue a warning, you know, that means business. That's what you should take it seriously. And again, lightning, flooding are threats as well. So in the year 2022, so everyone, or a lot of people have a cell phone nowadays. So something that we started is we now will trigger a WEA alert for what's called a destructive warning. So we issue a severe thunderstorm warning, and we now categorize those warnings. This goes in the printout, like the TV people get it. It's like really easy for them to read, so they can just rip it and go like on the air with what's happening. If we issue a warning now for what we consider destructive, so like 80 mile per hour winds or baseball-sized hail, that will automatically trigger your cell phone. So that's something new that we have done. If you're wondering what it might look like, so fortunately we haven't really had to do too many of these yet, at least at our office, but it might look something like this. These are the severe thunderstorm warnings, those yellow boxes. And you might say, well, that's weird. Like if I live in Green Bay, there's 2 warnings. Like, huh? Like, okay, that doesn't make sense. But the reason for that is, like, so say we have a line of storms, or say there's a line of storms that goes from like Madison to Janesville or something. But there's one area in that line of storms, in this case, it's that area like due west of Green Bay, that has 80 mile per hour winds. And we say the whole line doesn't have 80 mile per hour winds. So we don't want to issue a giant warning with 80 mile per hour winds and like send everybody's cell phones off and ringing and buzzing. We just want to get that pocket of 80 mile per hour winds. So in this case, we issued a separate thunderstorm warning just for that area of 80 mile per hour winds. So again, it might look weird to see 2 severe thunderstorm warnings at one time, but the purpose is just to capture that 80 mile per hour area, and then that would start triggering people's cell phones and let those people know, in this case, that are in Swamico, Howard, Green Bay area, you know, hey, like this area is going to be very bad things happening, so take shelter. Statewide, if you're wondering how often we might issue one of those destructive warnings, so in the Green Bay area, we average about 1 per year at the statewide level here. So this is a frequency chart of what categories or what thresholds are in each warning we issued. And so the numbers in the middle are percentage. So in this case, the number in red under 60 mile an hour winds and 1-inch hail that says 30.47. So that means 30% of our warnings have 60 mile per hour winds and 1-inch hail in them. So that's the most common that we issue. Then way to the right, going up and down is like the wind speeds. So like wind speeds of 100 miles an hour, very, very rarely, which is obviously good. But the areas in red, I put boxes around where that destructive category would be. If you add up the numbers, it goes to about nine per year, so in the state of Wisconsin. So not too many. And a lot of them, the Green Bay area usually has like 1 per year. So it's definitely more like a southern and southwestern Wisconsin thing. Again, severe weather hazards. Lightning's a big one, very, very underrated. If you're outside, the lightning basically looks for the tallest object. So if you're, in a field or somewhere on a golf course, and golf course has a big sprawling fairway and not a lot of trees in the fairway, but if you're standing there, especially if you're standing there holding a 9-iron, like guess what? You might be the best target nearby. So, if you hear when thunder roars, go indoors is our phrase. Then if the question is, well, when is it safe to come back out after lightning? Kind of the rule that we have is to wait 30 minutes after the last lightning strike or last thunder and then return outside. Yeah, fortunately, lots of lightning strikes during sports. If you're on the lake, again, the first thing right off the top is knowing the forecast before you head out. So that can be done when you first wake up in the morning. You're already aware of the forecast. So then you can check it throughout the daytime too if you want to stay up to date. And then making sure you have a way to receive that weather information. If you can get a cell phone out there, have a weather app with a radar on it, those types of things so you can stay aware. If you're camping, again, make sure you have a way to receive warning information. Being in your tent isn't necessarily the safest place. So, think of like a sheltered area, or if you're, not too far from a gas station or something, if worse comes to worse, know where that is ahead of time so that when a thunderstorm or if a tornado were to come, you wouldn't be panicking and try to figure out while that's going on. Speaking of tornado warnings, the state of Wisconsin averages about 24 per year. Texas is the winner at 136 here. Winter, of course, depending on perspective. So, yeah, not as much up here in Wisconsin. Michigan also, especially the UP, starts to get fewer and fewer in our area. So, we're talking tornado safety. This was my backyard. This was a couple of years ago. I had a 1-year-old at the time, and I finally got him down for a nap. Yay! And so I was tired too. and so I was taking a nap on the couch. And all of a sudden, I heard the winds, like in the backyard, just start going. And I looked and so I was like, kind of waking up, becoming less groggy. And I looked out the window, and that's why I took this video. I'm like, what the heck? And then my instinct was to record it. And then you can see debris and things. And then after 5 seconds here, my brain kicked on oh yeah, don't be outside. This looks like a tornado. And then sure enough, the picture on the right, I ran out to my front yard then. And that's what started in our backyard. And then that was the tornado. And this actually ended up, I think it was an EF1 or EF2 tornado that got stronger as it went further to the east. And so I did a damage survey on this, and I literally put the starting point in my backyard. So how many people can say that? But the moral of the story here is not my backyard, but what should we do to stay safe from tornadoes while at home? And a hint, it's not go and take video of it. So our biggest thing is we say to stay away from windows and don't go outside. So with a tornado, so the 100-mile-an-hour winds, if there was a fan in this room of 100-mile-an-hour winds coming at me right now, Like I might blow backwards a little bit, especially after a couple of brats, maybe I'll be more sturdy. But if I don't have those brats in me, I'll go backwards a little bit. But generally, I'll be fine, more or less. The problem would be for if we had those 100-mile-an-hour winds, and say we put a big glass window, and then we put a whole bunch of objects in between that fan and me. So now we have those objects flying around at 100 miles an hour. And that's where most of the injuries and fatalities occur with tornadoes and these strong wind events. If the glass shatters, now you have shards of glass flying around the room, however fast it is. And so that's the big reason why we say to stay away from the windows. It's not like the direct wind speed, but it's what those winds pick up and toss around and throw around. And if there's tree branches or 2x4s. So we say stay away from the windows. Try to go to the lowest room possible if you have a basement. If you don't have a basement, the most interior room with no windows, which is usually like a bathroom, is the safest place that we recommend. Then, of course, too, in the whole preparedness thing, if it's a big tornado day, it never hurts to have like an emergency kit or a supply kit ready to go. Worst case, you just carried a couple things downstairs for no reason and you can bring them back up. But should, heaven forbid it be needed, you might be glad that you have some of those things down there. For sheltering guidelines, so a lot of words on this slide, but basically you don't want to be in a mobile home or a vehicle or under an overpass. That's one of the more unfortunate myths that started spreading. I think it was in I want to say the mid 1990s or something. I think right when the internet was being invented. There was that video of a tornado, and it was in Oklahoma City. And someone went under an overpass and filmed it. It was oh, cool. And the tornado went over them and they were fine. But that's actually the worst places you could be. First off, if you're on an interstate, say you're on Highway 151, the speed limit's 70, and you're a parked car somewhere and people are flying at 70 whatever miles an hour, you don't want to have that intersection happen between yourself not moving and someone moving 70 miles an hour at you. But the other reason is actually a scientific one. If you think of a garden hose and you unscrew the nozzle and just water comes out the hose. And if you want to, as a kid, if you want to spray water in the face of your little brother or sister, you'd put your thumb under the hose and that would make the water shoot out faster and further and stronger. And that's exactly what an overpass is doing. Basically, the wind speeds have less of an area, less spatial area to go to blow from point A to point B across. So when you compact it, it'll actually strengthen the winds right in that location by the interstate, or overpass, I'm sorry. So we say never go under an overpass for several reasons. Otherwise, gymnasiums, open rooms are not a good place to go. So try to get to the interior. So that's why school safety, getting kids in the hallways is important versus putting them in the school gymnasium or the school cafeteria with the big open ceilings. That's not a good option if you can have enough time to get them somewhere more interior. So if you're on the road, again, I mentioned to not go under overpasses. And really, if you're in a car, your options, just being totally honest, it's just not a good place to be at all. Your best resort is to, if you can find a gas station or a sturdy building or somewhere to pull off and get inside, that's option A. But if you can't, it's just not good. Trying to find a ditch in a low-lying area is kind of the best recommendation. Then getting low and covering your head so that if things are flying around, so that I'm not a 6-foot standing target. If I'm crouched down low, at least only 1 foot of me is going to get hit by things. But you're just it's just not a good situation at all. So it's kind of the worst of the worst options available. Obviously, driving around and going the other way is preferred as well if it's possible. Depends on the road network. Tornado safety at night. I always put this on my spotter training videos. So one of the scarier experiences I had in my life, parents are in the audience, they should cover their ears, is when I was night chasing. So at nighttime, especially if you're in the middle of nowhere, you have no lights. And the only way you can see if there's a tornado is by looking for lightning flashes. So this video will repeat here. There. Quick lightning flash, and then the lightning stopped, and then it's blank again. So like in between these lightning flashes, you have to determine, like, first find the tornado, like, wait for it, there, oh, no, there it is, there it goes. So in that amount of time, you have to find the tornado, and then kind of like try to hold that picture in your mind, and then wait for the next flash and see, like, is this tornado getting bigger? Because if it's bigger, then guess what? It's coming at me. So you just kind of try to track how it changes in between lightning flashes. So yeah, I did that one time and one time only. Okay, parents can take your earmuffs off now. We'll never, ever do that again. That was, no thank you. So yeah, if you're at nighttime and there's tornadoes, just don't mess around with that. Storm damage. Storm damage ties into wind safety. So kind of a, I don't want to, that's what I'm looking for, like understatements. So like comparing it to baseball, like if tornadoes are the home run, you know, the things that capture the headlines and, you know, the big tornado, just straight line wind or strong wind damage is also a thing. Because guess what? In a tornado, winds could be going 100 miles an hour. In a straight line wind, winds could be going 100 miles an hour. Like, isn't that the same wind speed? Yes, it is. So therefore, like straight line winds can do the same amount of damage as a small tornado. So this was also my house. This was the June 19, 2019 or 2020 derecho in Iowa. So yeah, things seem to follow me. But, you know, you couldn't tell, like, was this a tornado? It looks very much like a tornado damage. So the moral of the story here is if it's a severe thunderstorm warning and, you know, we have like that 80 mile an hour tag or that 70 mile an hour tag in it, don't just say like, oh, well, it's a severe thunderstorm warning. It's not a tornado, so, you know, that's fine, whatever. Like, no, very, very much not true. Like 80 mile an hour winds can still do this damage, which looks very much like a tornado damage. So, you know, make sure you take that seriously as well. And then straight line winds can also knock trees over to power lines and those types of things. So make sure to avoid, you know, power lines if you see a down power line. Switching gears a little bit to flooding. Here's a graphic. So 6 inches of fast moving water can knock over a typical adult. 12 inches of water, a small car, and 18 to 24 inches, your SUVs and your trucks. And I don't know how many videos I've seen of people like, you know, I've got a Ford F-150, vroom, vroom, here I go. And sure enough, like there they go down the river in the flooded street. So it doesn't matter like how big your vehicle is at some point, like the water is going to win, I guarantee it. So we say, you know, turn around, don't drown. And if you can't tell how deep the water is, you know, don't risk it. Like try turning around. If it adds 2 minutes to your time to have to take a different road, like, you know, I'd probably prefer that option than the financial whatever of my car being submerged in water. So, and then also too, most flash flood fatalities occur during nighttime by a considerable margin. And that's just because people can't see how deep the water is. And so, you know, they guess and hope for the best, and yeah, bad things can happen. Like if you're in a smaller car and the water is deep enough, like your car can get flipped over pretty easily, and it all happens so fast. It happens in like seconds. I've seen video of it happening. You know, the car is just turning to the right, and then literally like 3 seconds later is upside down and underwater. So like it just happens so fast. So we say, again, like if you don't know how deep the water is, don't risk it. And yeah, it doesn't take much to knock you off your feet on a sidewalk either. Heat inside the vehicle. So doing experiments here. So the outside temperature in the upper right of this graphic is 80 degrees. And if your car is sitting in direct sunlight after an hour, the inside of your car can be 123 degrees. Someone put like a thermometer on their dashboard. So if the outside temperature is like today is like 100 degrees, like it can get to 123 degrees inside your vehicle pretty dang quickly. So, moral of the story here is our phrase, for flooding, we have turn around, don't drown. For thunder and lightning, we have when thunder roars, head indoors. And our phrase for heat is look before you lock. And, it's an incredible travesty that every year there's fatalities. It's terribly tragic, like people leaving their pets or their small children in the back seat and going shopping or doing whatever. Then they come back and, yeah, not good things have happened. So look before you lock is our big phrase there. Heat safety when you're outside. And yeah, that's the thing. Like most heat-related deaths are generally preventable most of the time. Not all the time, but a lot of the time. Like checking your back seat, like making sure you didn't leave anyone in the back seat who shouldn't be in your back seat. Like that's preventable. 2, making sure you limit activities, wear light clothing. There was a really good graphic from the Weather Service in Kansas City. They had shirts of different colors. And they lined them all up next to each other. There's like a white shirt, a blue shirt, and a black shirt. And they took like a thermometer gun and like left the shirts outside for like half an hour. And then they pointed the thermometer gun at the shirts and like took the temperatures. And it was amazing. It made a huge difference. And I never like seen actual like I know like, well, I'm told to wear light colors, but I've never seen it before. Like that was actually the data. It's like, that's pretty wild to see. But the light colored shirts were like 15, 20, 30 degrees almost cooler than the dark colored shirts. So I thought that was pretty fascinating. So wearing a light colored clothing too, if you're gonna be in the sun, is very helpful. Purposeful transition from all the heat right into fall and winter. So, question for the audience, snow squall warning. We ever heard of that before? So this is something that the Weather Service started doing in the year I think we experimented in 2019, but we went full green light for the whole Weather Service in the year 2022. So snow squall warnings are being issued across the country, so every Weather Service office is doing it. And these are like short fused warnings. So if you think of like a severe thunderstorm warning, how it's usually like a box somewhere, like a box that's over like Dane, Sauk counties moving eastward, and the box just continues. Snow squall warnings are very similar to that. So short fused, a short amount of time, like think 30 to 60 minutes. And here's an example of what a snow squall was in Iowa. So again, this is during the winter. And, on the radar, like, well, it doesn't look too whatever, fine. But the moral of the story with this is like, if you're in eastern Iowa, like the sun was actually out beforehand. And then like, as this snow squall went through, it went from 0 to like very bad, like in minutes. And here's the observation. So again, a lot of numbers here. So at the bottom is like 10 a.m. and at the top is 1:52. So the time kind of goes from get earlier in the bottom to later in the top. And then the column on the right is the visibility, and then there's wind speeds. So visibility at 11:59 was 5 miles. Visibility at 12:25 was 6 miles. Visibility 12:28 was 1.25 miles. Visibility 12:33 was 1/4 mile, which is probably actually less than that, but 1/4 mile is the lowest that this sensor had. So if you do the math, in a span of 8 minutes, the visibility went from 6 miles in fine, hey, the sun might have even been out, to like less than 1/4 mile, heavy snow, 37-mile-an-hour winds. I can't even see in front of my face. So that's what a snow squall warning is. And like, this is what it looks like on radar. And here's a picture of, unfortunately, what this snow squall did as it went right along Interstate 80 there. I think there were 1 or 2 fatalities. That's the big challenge of things when it goes from 0 to bad really quickly. You know, think driving. Like the biggest thing for accidents that we're finding during winter weather is different travel speeds that people go. So you have someone going, you know, we think back to our memories, we've probably all seen it, like someone going 50 miles an hour through snow, and then all of a sudden a semi goes 70 miles an hour, and then some young Yahoo is going 90 miles an hour, and someone else is going 40 miles an hour. So when you have all of that, like on the interstate, that leads to unfortunate things like this. So if you see snow squall warning, this is basically what we're forecasting is like that very, going from fine to very bad in a short amount of time. And then to round it out, on the backside of this, I forgot to do that, at the very top, you can see there about like 114 and 152, the visibility's back up to 5 or 6 miles. So it's not a prolonged thing. It was just very, very short burst of very heavy snow, and then it got better. And so if you're wondering like what the difference is between that and a blizzard warning or that and a winter storm warning, it's mainly the duration of it is a big thing. So like a winter storm warning or a blizzard warning, those last over 3 hours, oftentimes like 6 hours or so. So 6 hours, winter storm warning, blizzard warning, versus like a short-lived 30 to 60 minute snow squall. Like the impacts could both be the same, like it could have whiteout conditions. It's just kind of the way in which those impacts happen is what is the big difference. And yeah, and there's no minimum snowfall accumulation for a snow squall. Like you don't need to have 4 inches of snow or whatever. You could just have like a half an inch of snow. But if the snow is enough to cause whiteout conditions, then that would qualify as a snow squall warning. And oftentimes too, something to back pocket is oftentimes with a snow squall warning, right behind it, there's a big temperature drop. And so like it could actually kind of be like a flash freeze type situation where like during the snow squall warning, it could be like, I don't think I have temperatures on here. Yeah, I do have temperatures on here. Good for me. So, so that's what these numbers in the 20s are. So like at 11:59, it's 29 degrees. At 12:25, it's 27. And then notice it's all the way, so from 27 degrees at 12:25 to 22 degrees. So the temperature fell 5 degrees during that short amount of time. And when you start getting into the 20s and teens, that's when like freezing on the roadways can happen much easier. So that's something else to keep in mind too. So like the snow is gone, visibility is 6 miles, but now it's like 10 degrees colder than it was just an hour ago. And so that could lead to slippery conditions on the roads too. That's something else that we're like learning is a science. Like snow squalls have probably always have happened. Like this isn't something that just started, the first time it's ever happened was in the year 2022. This is just how we first like kind of got our head wrapped around it and like the impacts of a snow squall warning. And we actually have some science to the forecasting and like ways to communicate the impact and the hazard. So we're like wrapping our head around like defining what this weather event is. The weather events happened, for the past whatever decades, but now we know how to communicate to people, and hopefully this will keep people safe and help us carry out our mission of protecting life and property. So if you're unfortunately in a snow squall, things we say, slow down but don't slam on the brakes, because again, that's where you have the person going 80 miles an hour behind you who doesn't slow down. Turn on your lights, low beams hazards, and try to exit safely, and just kind of just wait it out. That's the quote unquote good thing about the snow squall warnings is, again, they're short fused, so it's not like you'll have to wait it out for a couple of hours. It should just be for 30 to 45 minutes, 60 minutes sometimes. So contrasting that with blizzard. So blizzard, blowing snow, 35 plus mile an hour winds. And there's no snowfall requirement either for a blizzard. Like you don't have to have 3 inches of snow, 4 inches of snow. It's just the impacts. that less than a quarter mile visibility for 3 hours. So if you hear blizzard warning, don't necessarily think, gosh, there's gonna be a foot of snow now. There can be, but there isn't always a foot of snow. In fact, sometimes there isn't even shovelable snow in a blizzard warning, because it's blowing around. So it's not the amount of snow, it's the impacts that the snow causes. And that's why we're to blizzard warnings and to snow squall warnings, it's the impacts that those things cause that we're really keying on. Then winter storm warnings as well. Usually those have usually six inches of snow or more. Those we're looking at those as the Weather Service as well. We're in the process of modernizing those because, as we know, 6 inches of snow in Wisconsin is different than 6 inches of snow in Texas. That would, my gosh, shut the state down. But here, 6 inches, what do you call that? I call it Tuesday, So we're working on kind of modernizing that. So when we see a winter storm warning, it's usually an abnormally high amount of snow that we don't typically see that would cause bad impacts. Ice storms are a thing as well. The biggest things that those do is those go onto tree branches, and the tree branches sag and go onto power lines. So there could be a lot of power outages. Usually the power lines themselves can handle ice in most cases. If there's any power utility people here, feel free to correct me, but I've been told that the power lines can typically handle it. It's the tree branches that fall onto them is what causes the big problems. So, don't park your car under trees, and just make sure that you're prepared in case there would be no power. Any devices that need power, you have spare batteries or generator if you need it, that type of thing. A little bit of science of wind chill. So how does the wind chill work? Why, on some days when it's windy out, does it feel colder than others? This is the basic science behind it is, our body is 98.6 degrees. When it's windy, the wind kind of takes that heat and radiates it away from us. So our body starts to feel colder because at 98.6 degrees is, we're kind of starting to lose that a little bit. So the big thing we say with cold weather is to make sure you dress in layers. So it's easy to scale down or scale up and try to cover exposed skin, that type of thing. I know this sounds silly when we're talking about 110 degree heat indexes, but this is how wind chill works. So when the days are really windy, that's what happens with the wind in our temperatures. So wrapping it up here, again, I want to end with this slide because I think this is the most important thing to do. And the best part also, which I didn't mention, is you don't need a weather degree to do this. You don't need to take the math and science. I think this patch of gray hair is from the math and the science portion of it. You don't need to worry about that. Just find your favorite local TV meteorologist. And we actually work really well with them because we each understand our swim lane. We know we're not TV personalities. So we just try to get them weather information, and we understand that they are television personalities. So you guys go on air and be flashy, and we'll just stay at our little desks and with our pocket protectors, and we'll do all that. So the community itself works together very well. So I definitely would endorse checking their forecast, again checking our forecast, some trusted source. But just take 60 seconds every morning to do that. Think of where you might be when there's severe weather. Make sure you have a way to receive the information, and make sure that you have a shelter to go to if you need to. And stay safe.